Alright guys, so part 2 of our 6.6 notes jumps into application, mainly work type problems, like one individual doing a certain amount of work and then two people doing it, or two people and then what if you take one away, and trying to figure out how long a job would take. So up on the screen you guys should be able to see the x over time plus x over time equals one job, or in this case it would be yard work. So we're going to jump in how we would fill that in. So we would have X, actually let's take a step back. We would have Mark can complete his yard work in 15 hours. His father can do the same job in 9 hours. So let's put those up first. How long will it take them to finish the job if they're working together? So we would have Mark plus the father equals the one job. So that's our kind of generic outline. So what we'll have is X over time, and we said that Mark was 15, plus the father, which is X over his time, which is 9 hours. And they have one job to do, which is to finish the yard work. So they're working together in this case because we're adding their time, their capability together. All right. So what we're looking to find here is what would the greatest common factor be with 15 and 9. All right, so with 15 and 9, we start to kind of lay those out with multiples. So we got 9, 18, 27, 36, 45. So I'm going to stop there because then we'd have 15, 30, 45. All right. So we've got our greatest common, or our least common denominator there. So we need to multiply the 15, top and bottom, by 3. We need to multiply the 9, top and bottom, by 5. Now we're trying to get to 45. So keep that in mind when it comes to our 1. That needs to be multiplied top and bottom by 45 so they all match. So once they all match and they all have the same least common denominator, what we did in the previous part is going to carry over now to where we want to get rid of the denominator, so we multiply by the reciprocal. So those are gone, so we're left with 3x plus 5x equals 45. So 8x equals 45. So x equals 45 over 8, which is approximately 5.65. All right, 5.625 hours. All right, so that if they work together, so individually the father can do it in 9 hours, the son can do it in 15 hours. If they work together, they can do it in a little over 5.5 hours. So that's pretty good teamwork that they got going. All right, the next one, we still would need x over time and x over time. It's just now we have Janice can tile the floor in 14 hours. All right, so Janice, it takes 14 hours. And then Bill can tile the same size floor in, let's see, oh sorry, Janice and Bill together can do the same size floor in 9 hours. So how long would it take just Bill to do the job if he was by himself? All right, so what you'd have to do is take them together, which we said was 9 hours, so the job over time, and then subtract away Janice's time. So subtract Janice's time to find out the one job that Bill could do by himself. So we said that by herself, Janice could do the job in 14 hours. She could tile the floor in 14 hours. And that's over one job. Now with 9 and 14, you are trying to find multiples, and instead of writing all of them out, because I would end up getting up to 9 times 14, I'm just going to multiply one by the other. So if we multiply this by 14, and the second fraction by 9, we know that will at least give us a common denominator, but because we've looked at it, then we know, okay, that is our least common denominator, which would give us a 14x up top, and that's over 126 minus 9x over 126, and make sure you do remember to multiply this by 126, so by what we're trying to get as a least common denominator. Once we've done that, so we've got our denominators all the same, we could flip and multiply, like we just saw, multiplying by the reciprocal, or we can just drop it, meaning we know it's going to cancel out anyways, so we'll just drop that part. So that leaves us with a 5x equals 126, divide by 5, divide by 5. So that's x equals, we know is going to be close to 25, so 25.2 hours would be Bill. So Bill's slacking a little bit in comparison to Janice. All right, last one is if we are using 3 items now. So we have 2 pipes that are filling up the water tank. 1 pipe alone can fill it up in 27 minutes. 2nd pipe alone can fill it up in 50 more. A 3rd pipe, it can empty it all in 36 minutes. So what that means is you're emptying, you're taking away. So if we are saying 27 minutes for one of them and 54 minutes for another one, and then if we are talking about it being emptied, then we know that we need to subtract there, and it's still over 1 task, which is either filling or emptying the water tank. So finding our multiples there, let's see, we got 27, 54. This one's already 54, so that's a good sign. And then we're saying, okay, if we're at 54, how much farther do we need to go? All right, 81, 108, 54. There we go, 108, so that's good. All right, so we know that we need at least that. And then we would say 36, 72, 108. All right, so we're in business. We got to our least common denominator. So for our 27, we had to multiply that by 4, top and bottom. For our 54, we had to multiply that by 2. And then for our 36, we multiplied that by 3. And then don't forget, we need over here to be 108. So 4x, and I'm just going to drop that denominator because we flip and multiply by the reciprocal. Alright, so we've got a 4x, a 2x, and a minus 3x. So that's 6 minus 3, so that leaves us with 3x equals 108. 108 goes into, or 3 goes into 108 36 times, and so it would take about 36 minutes. Alright, so those are the types that you could see for your application problems. So hopefully that helps, and I know we've got a couple in the practice that you'll be able to put these into practice.